many transformations. You did this in middle school, so it shouldn't be too new to you, I guess. Right? It's a geometric figure, or even just anything that changes in position, shape, or size. Changes in position, shape, or size. So some of the main transformations, well, we already did the one that changes in size. What's that one called? Dilation. So we already did dilations. Some of y'all still don't know how to do a scale factor for a dilation, so you better figure that out before Friday. The other three are when a figure flips, okay, which y'all know it as what? There's no R. Reflection. The other one slides. It's like up, down, left, or right. Translation. And then the other one that turns, which is rotation. Okay? Not sure how much detail y'all got in middle school with this, but you're going to be able to know the rule. You'll be able to graph it. And yeah, pretty much it. You already did pre-image and image. Okay, the pre-image is the first picture or the original figure. The image is the resulting figure. So the new. So if you want to write new and old, do that, whatever it takes. Because some of y'all got that backwards on the quiz. Okay, because I said this is the pre-image, this is the image, and yet y'all gave the scale factor or the ratio backwards. Okay, this one is the first. This one is the second. Did you put collateral or borrow a pencil from me? Because it says that on the jar. Put collateral. Isometry. The transformation in which the pre-image and the image are congruent. So be able to identify what an isometry is. The key word here, if you can just remember that, pre-images and images have to be congruent. So keyword congruent. If they're not congruent, then it's not an isometry. So based on being congruent, the only one we've done is dilation. Would that be an isometry? So they're congruent figures? No, one is smaller, one is larger. Those are similar figures. So basically, all the rest, those would be isometries. Okay, everybody got definition? Who's still writing? Raise your hand. All right, so let's test. Is A an isometry? No. They're not congruent. Is B an isometry? Yes, that works. Okay, so B works. What type of transformation could this be? Reflection, translation, or rotation. So that could be any of those. So it could be any type of transformation depending on where it's at. Would C be an isometry? Yes. What kind of transformation would that is? Reflection. What else? Rotation? Just reflection. That's it. All right. Notation. Some notations that you gotta know. A transformation maps a figure onto its image. There's that word again, image. Make sure you know that one. And is described by an arrow notation. Write those in. So arrow basically means maps onto. It means maps onto it. So if you hear me say triangle JKQ maps onto triangle J prime K prime Q prime, that's what it means. Maps onto means just saying which one's the first one and which one's the second one. Prime notation. Prime is that apostrophe. I think I briefly mentioned it on one of your class assignments. So the apostrophe is going to always describe the image. Make sure you highlight image. So the new one. So So in this figure, using all of these notations, you've got K prime. That's going to be your image of K. So the way you write it using the arrows and the apostrophe, say K maps onto K prime. To state the whole entire polygon, triangle JKQ maps onto triangle J prime, K prime, Q prime. Again, the arrow means maps onto. So if you read that or you see the arrow, you got to understand what that means. We're going to use the arrow to write the rule. You'll be able to write a rule for all types of transformations. What type of transformation is that right there? Is that it? Area rotation. Just reflection. Okay, everybody got these blanks filled out? Alright, let's talk about the first transformation, and that's the easiest one of the three. Okay, making the rules. Okay, go back. No. Okay. Making the rules easy. This is the easiest one. So translation. You can summarize the whole sentence up the front, you can, but you need to write something down so you don't forget it. This one is just slides. Okay, it's going to be isometry, but the shapes are going to be identical. Nothing changes in size. All of the points, the 1 point slides 10 units, all of the points have to slide 10 units if you're dealing with a polygon of some sort. Okay? So for instance here, you have, this is the free image right here, and it's being mapped onto this one over here. Okay, so what happened here, it's split to the right and down. How many? It says there, 9 units to the right, 3 units down. So here's how you would write your rule. X comma y maps onto x plus 9, y minus 3. Did y'all write these rules in middle school? No? Okay, so make sure you pay attention because I may give you a picture, you have to write the rule. Okay, we're practicing that here in a second. I may give you the rule, you have to crash the picture. Okay? And I'll always give you the free image. Okay? Or maybe you work backwards. I'll give you the image, you gotta give me the free image. So it's a plus 9 on the x value. Okay, right here, plus 9. Why positive and not minus? Because it refers to the x values, and where are all the positive values for x? To the right, okay, right? The numbers get larger and larger and larger. So anytime you move to the right, you're going to add. What about if you're sliding to the left? What are you going to do? You're going to subtract. Okay? What about for the y? Why does it say minus 3? Because you're moving down. So anytime you're going down from the negative low numbers, you're going to subtract. How about to go up? You're going to add. Okay? So simple as that. Okay? That's why I think this one is the easiest, so we just add and subtract. Alright? Write that down. Okay, do the next two on your own. The first one, you have to draw the image, given that rule, and then in the second one, you got to write the rule. Okay, so do that on your own. I'm going to call on one of y'all to give me what you got. Factorizing your coordinates for x prime, y prime, z prime. Alright, look right. Did y'all come out like that? Yeah? Okay, real simple. You know that it's going to slide left how many? 8n of 3. Okay? Use the minuses and pluses to help you out. Okay, so let me know that. 8, yep, of 3. Okay? Alright, we need the rule to the next one. Writer. We need a rule. No. That's how it starts. Okay, you go x, y. Not 2. Y minus what? Y plus what? 11? Alright, did anybody else get that? You got that?
Yeah.
Minus 11? So they're both minus? Yeah. Okay, so that's a good example on how you guys know that all these primes right here, that means that's the what? Image. And remember I told you on your last set of assignments that you have 16 years and you should write image and pre-image. Okay? Image, this one's the pre-image. Alright? So, let's start. Okay, so easiest transformation of the 3. Okay? Next one, still somewhat easy, but a little bit more challenging depending on certain things. Okay? This one's the reflection. This is also going to be isometry, meaning the figures are going to come out exactly the same. But just think that it's going to have like opposite orientations. Okay? So like for instance, here's the original one. It flips over on the opposite side, the exact same distances for every single one. Okay? So this figure is being reflected over the y-axis. Okay? That's really important because it's always going to be over something, over some sort of line. And then that's called a line of reflection. So make sure you know what a line of reflection is. It's also sometimes calls it a line of symmetry. Alright, so either line of symmetry or line of reflection, and you get that same thing. Okay, this rule here, here's how you figure out the rule. Okay. Test a couple of points and see what they are. So let's just do B. Or let's go C. C is 1, 2, 3, negative 3, 1, 2, 3, 4. C is at negative 3, comma 4. Check C prime now. C prime is at 1, 2, 3, 4. Positive 3, 4. Okay? Check D. That's 1, 2, 3, 4, 5. Negative 5, positive 2. D prime is positive 5, positive 2. Do you see the relations there? What happened? The x was negative, but then it what? Then it changed to positive. So it went from a negative to a positive. What happens to the y's? The y stays the same. So when the sign changes, don't think translation, because I already had somebody in the last class period say, oh, add 6, because it slid, I guess, to the right 6 at one point, but not the whole figure. Okay? put a negative in front of that variable. Okay, so highlight and star that rule, because this is the rule always for a reflection over the what? The y-axis. There's our line of reflection, and that's the same rule for anything that reflects over the y-axis. Okay, so this one's pretty easy. Just when we start throwing in other types of y-axis that you're going to see here in a second. Everybody got this down? Yes? Alright, so let's take a look at these two right here. So it says graph the image of triangle X, Y, Z and reflect it over the x-axis and then write the new rules. Okay, so we're going to reflect this one over the x-axis. It'd be a good idea to either get a color pencil or a highlighter and highlight your line of reflection. So you know you're flipping over that thing. Okay? And then just do 1 point at a time. Okay? 1 point at a time in opposite direction. Opposite orientation like we wrote down in our notes. So let's take a look at X. How many units is X away from our line of reflection? 2. So just go 2 in the opposite direction. That's going to be your X prime. So label it. How about Y? How many units is that away? How many? 4? 3. 1, 2, 3. And so then go 1, 2, 3 in the opposite direction. That's Y prime. How many units away is Z? 3. 1, 2, 3. Go 1, 2, 3 in the opposite direction. There's Z prime. Now just connect the 3 dots. And so that red triangle that I have is the image of that reflection. Okay, over the x-axis. Okay, so make sure you highlight that. Over the x-axis. Okay, so now we have to write the rule. Anybody know the rule? X comma y maps onto what?
X comma y.
Very good. But the only thing that changed was the y value. It changed in just the sign. So if you want to test out a few, you can. This one was 2, 2. And then the new one became 2, negative 2. This one was 4, negative 3. The new one is 4, positive 3. You see how the signs just changed on the y value? That's it. So highlight that rule. That rule is always the rule for flipping over the x-axis. Okay, highlight it, star it, do whatever it takes. Okay, because these will not be on your formula chart or anything. Alright, let's get that one over there. Graph the image of EQRS over the line y equals x. So see, this is not a simple x-axis, y-axis now. It's over the line y equals x. You all even remember what that line looks like? Diagonal, right? So draw that. There's your line of reflection right there. Okay, so draw your line, maybe another color or whatever you want to do. So we're going to reflect over the line y equals x. Okay, do the same exact concept that I did there. The only difference is now is they are kind of at a diagonal. How many diagonal units is R away from our line of reflection? 2 diagonal units. Okay, so 1, 2. So then just go 2 diagonal units in the opposite direction. 1, 2. There's R prime. How many diagonal units is Q, y'all? How many diagonal units, Cody? Yeah. What did we just do a second ago? Or did you not do it? We said R is 2 diagonal units away from there. So we're going to go 2 that way. So how many diagonal units is Q away from our line of reflection?
I'm not sure.
Can you just count the diagonals and then you draw it with your pencil? Look, 1, 2. Do that for Q. How many diagonal units is Q away from the line of reflection? Draw it out. Draw the diagonal so you get to the line of reflection. 9? Did I ask you 9? What did you get, David? What did you get? You already counted when he was counting. Just tell me what you got before. It's okay if it's different. 4.5? Who else got 4.5? Okay, so let's go. Here's how you count it. Now I don't know if anybody else got it wrong. 1, 2, 3, 4, and then a little half. Diagonal units away from there. So you're going to go 4.5. Okay, notice the half has to come first, right? So half, 1, 2, 3, 4. Here's where Q prime is. How many diagonal units is P? You know? How many diagonal units is P? 6. 1, 2, 3, 4, 5, 6. So now let's count 6 diagonal units. The opposite direction. 1, 2, 3, 4, 5, 6. There is P prime. 1 more to go. How many diagonal units is S away from the line of reflection? Huh? 4.5 again. Yeah, 4.5 again. Half. 1, 2, 3, 4. And then count in the opposite direction. There's S prime. Okay, now draw your figure out. There it is. That is a reflection over the line y equals x. Anybody get the rule yet? How many of y'all thought it was going to come out like this? Everybody draws that every year. Okay? So make sure you do the properties that I just taught you. Okay? It did not come out like that. That's the reflection. All right, what's the rule, guys? X has a line wraps on the what? Did I get right? You're wrong? Sure. How can you tell if you're right? What do you do? What did I say to do the last time? Look at some of those points. Okay? Let's look at Q. What point is Q at blank? Q. -3, comma. Alright. Dylan, what is Q prime at? Okay, now look, compare those two, guys. Compare this one, the new one, with the original one. What happened there? All they did was switch, right? So what do you write now? What is it? That is the rule, always and forever, for the reflection over the line. Why was it? I would highlight that and start it and do it. Okay, so this is all next to that. Please remember, all you do is flip them.
Are we going to put the diagonal on the thing?
You could probably have the diagonal in test. You could probably have it anywhere. Anywhere that you can grasp, you'll be able to reflect over.
Will it be drawn for us?
No, you will have to draw it.
Oh.
This is a simple diagonal. Were you able to draw diagonal just a second ago?
I can't draw a straight line.
Okay, but can you count diagonals? Can you count diagonals? Yes or no?
Yes, ma'am.
Yes, you can. Look, here's how you do that. Just go like this. Start at the origin, and then diagonal, diagonal, diagonal. See the points? Do all the points if you have to. Go all the way to the corner. Look at all those points. Just go down the diagonal. And then you just get the points. And then you'll be perfectly straight. Yes. What is it? What?
Is there a more mathematical way to do it than counting diagonals?
By counting diagonals?
Yeah.
Here's a mathematical way. Remember that rule. Okay?
Oh, right.
And you don't have to count diagonals. Okay? Alright. That was just to get you to figure out the rule. But now that you know the rule, you don't have to do the diagonal counting. Okay? Now, what are the odds of you remembering this rule along with all the other rules?
100%.
Okay? So if you can memorize it, you're good. If you don't memorize it like me, like my memory's not very good, all I would do is count diagonals because I think it's pretty easy. Count it. Okay? Alright. Here's that one. Last one. This is the most difficult of them all. The rotations. Okay? Alright, so rotation is going to be turning about a point. Alright, so when you turn, it is in my symmetry because the figures are going to come out identical. And you're going to rotate it X amount of degrees. And then about a point. Now the point that we're always going to probably rotate it about is the origin. Okay? Just like it is in this example. And the most frequent way that we are going to turn is counterclockwise. Okay? I'll try to be specific and tell you turn counterclockwise. Okay? If not, then just ask and I'll say yes, we're counterclockwise. Okay? Alright, so this figure shows a rotation of triangle ABC being rotated 90 degrees. 90 degrees. Okay? Counterclockwise, of course, because I just said that. That's still where we normally go. So just imagine here it is, and it's turning like that 90 degrees. Now, how do you know for sure that it goes 90 degrees? You do this little drawing of a line, which I already have drawn. That green dotted line goes to the center. That's for A. Well, if you draw this first, you say to yourself, how do I make a 90-degree angle? Well, what do you remember about this and this? And opposite reciprocal slopes. So this slope is a positive slope. It goes over 6 up 4. So think of opposite reciprocal. Okay, I just say it goes over 6 up 4, rise over run. Positive. What's the opposite reciprocal of that? Negative 6 over 4. So go from the origin and go over 4 up 6, okay, or up 6, 4 that way. So that way it's a negative slope. And there it is right there. Okay, and then once you just do one point, you should be able to come up with the rule. Yes, so what was A originally at? What was that? 6, 4. Okay? And then I did the opposite reciprocal to make that 90-degree angle. What's A prime at, Bill? Say it again. Negative 4, positive 6. Now, focus on those two numbers. Focus on this number, the original one, this one, the new one. Okay, they have some similarities. What did they do? Negative y, x. So they switched, right? They took well like the one before. But one of the signs changed. The 4 now became a negative 4. So here's how you write the rule. Negative y, x. Okay? Highlight that, star 270. 270 degrees. So if I tell you guys on the test, hey, rotate it 270 degrees clockwise, you got to know that it's the same thing as this. Okay? 270 degrees clockwise is the same thing as 90 degrees counterclockwise. So do you want to write that down? Because we aren't just staring at me like, oh my God, write it down. But this is the same as 270 degrees clockwise. Okay, I'll write it for you too. Same as 270 degrees clockwise. Alright? Okay. If you can memorize that rule, fine. If not, you have to do this green line thing right here. Okay? You have to do that 90 degrees out the three stops. Okay, let's do the next one. This one right here is fairly easy. Okay, so that's a good thing. 180 degrees. So here's what 180 degrees looks like. We get that green dotted line going in. So think about it. If I'm going to do A, there it is. How many units is the same as the other one? What was it at? 6'4"? Right? So think about it. Keep it the same. 6'4". That's straight line. See how that's a 180-degree turn? Does it matter clockwise or counterclockwise? On the 180 turn. Okay, so this right here, 180 degrees. Or even that direction. Okay? So this right here is A prime. Alright? So A originally was 6'4". We just said that. What's the new A prime now? -6, -4.
Don't you already know the rule, so you don't even have to do that?
What is the rule?
Isn't it x, y matched to -y?
Look at these right here. The original one was 6'4". The new one is -6, -4. What's the rule, guys? Yeah, no, we think that changed with the sign. Okay, so that's why I said this one's kind of easy. So now you know the rule. It's x comma y maps onto -x, -y. Okay, highlight that rule.
So this isn't like the other ones where you have the same rule times everything.
No, I didn't say it applies to everything. I said it applies to every turn that is 90 degrees. You're talking about the one that we just did?
No, I was thinking about the other ones because I thought it was the same as the other ones where you could still use the reflection rule for all of them.
No, it just is just for those particular ones.
So can we use the rules that we did on the reflections for any type of triangle or any type of shape? Because like on the one we're doing right now, you guys use a different equation.
You have to do a different rule.
Yeah.
Like if you were reflecting over the text. The x-axis. Y equals negative. Y equals that. You have to reflect those. You have to reflect. Okay? You can't use reflection for rotations.
I know that.
Okay, well, I didn't know what you're saying.
I don't know either.
Okay. All right. So anyway, here's your rule. So then use that rule now to write down the other 3 points. Okay? Use that rule to write down the other 3 points. So C is at 8,2. Where's C prime at now? Oh, sorry. 1. 8,1. Where's the C prime at? -8, -1. There is C prime. Okay. E is at 3, -3. What is C prime? -3, +3. Change the sign of both of them. There is B prime. And so I draw this in one. So the blue triangle is a rotation of this triangle 180 degrees. Just memorize the rule, okay? Which is the easier of the three rotations. Okay? All right, last rotation, 270 counterclockwise. All of these are counterclockwise. 270 counterclockwise, which is also the same thing as what y'all? 90 degrees clockwise. Okay? So that's what you should work with right there. Okay? So let me get my green dotted line again. Okay. I'm going to go with A again. So draw it to the point of rotation. Now, this is down or a positive slope of 6 over 4. Okay? So what's the opposite reciprocal of that? The 4 over 6. So I'm going to go 1, 2, 3, 4. 1, 2, 3. Nope. You know that's a 90-degree angle? Yes or no? Okay, this is 90 degrees. This is a 270-degree turn counterclockwise. So right here is A prime. Okay, and again, all I did was stick to the slope, which is something you already know. This slope right here from origin to A was 4 over 6. 4 over 6. So opposite reciprocal is negative 4. I mean negative 6 over 4. Okay, so go from the origin down 6. So you have that negative 6. All right, what is A at 4 comma 6? What is A at, y'all? 6 comma 4, right? What's A prime at? 4 negative 6. Okay, focus on those two coordinates. This one and this one. And let's write the rule so that way we don't have to do this thing over and over again. What's the rule, guys? X comma y. That's on 2. Y negative x. Okay, highlight that rule. Star it because this is always the rule for a 270-degree turn counterclockwise or 90 degrees clockwise. Okay, if you memorize that rule, then you don't have to do the green dotted line stuff. Okay, because that's how you figure out the 90-degree turn. All right, so let's do the other two. C again was at H1. So if C is at H1, what's the new C prime? 1 negative 8. Very good. 1 negative 8. C prime. B is at 3 negative 3. There's a rule to 3 negative 3. What does it become? What is it? Negative 3, negative 3? Agree or disagree? Agree. That is correct. Okay, because think about it. They flip, but you have to change the sign on the X to make it. Okay, this is B prime. So here's the new triangle. Okay. That's a 270-degree turn.